ഹലോ എവ്രി വൺ, വെൽക്കം ടു വിന്നേഴ്സ് ക്ലാസ് റൂം. ഞാൻ രമ്യ. വിന്നേഴ്സ് ക്ലാസ് റൂം എന്ന ചാനലിലെ ക്ലാസ്സുകൾ നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ഈ ചാനൽ സബ്സ്ക്രൈബ് ചെയ്തതിനെ സപ്പോർട്ട് ചെയ്യുക. അതുപോലെ ഈ ക്ലാസ് നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ലൈക്ക് ചെയ്യാനും ഷെയർ ചെയ്യാനും മറക്കരുത്. Through this video, we are going to discuss CBSE Class 10 Math Chapter 1 named Real Numbers and textbook exercise 1.2 questions 3 to 7. Okay. This is the first part of the third question in exercise 1.2. Find the LCM and HCF of 12, 15 and 21 by applying prime factorization method. Okay, we have to do prime factorization for the three given numbers 12, 15 and 21. This can be divided by 2, we'll get 6, then again by 2, we'll get 3. 3 is also a prime number, no? So, we can stop it there. See, this can be divided like this. This number can be divided like this. See, prime factorization is over. That is, 12 can be represented as 2 into 2 into 3, right? 2 into 2 into 3. And 15 can be represented as 3 into 5. And 21 can be represented as 3 into 7. So from this we have to find what is the LCM and HCF. Okay. LCM, common multiple, least common multiple. We have to consider all the factors coming here, and we have to consider the maximum power of those factors. Okay, see which are the factors here. 2 is there, then 3 is there, 5 is there, and 7 is there, right? Now 2, maximum power of 2, here it comes. See, 2 comes 2 times, 2 here 2 square. 3 comes only once in all these three numbers, right? Only one time it is there, so it's enough. 5 is also like that, only one time, and 7 is also comes just for one time. So 2 square into 3 into 5 into 7, that is the LCM. 2 square is 4, 4 into 3 into 5 into 7, 4 into 3 12, 12 into 5 60, 60 into 7, so 420 is the LCM. Okay, now comes the HCF, common factor, highest common factor. Okay, now let us consider all the factors here. 2 is there, then 3 is there, 5 is there, and 7 is there. See, 2 comes only in this number, right? 12. 2 comes as a factor for 12 but not for 15 and 21. So we cannot consider 2 because HCF is common factor, something related to common factor, highest common factor. See, 3 is here, here and here. 3. For the 3 given numbers, 3 is a factor, so I can take 3. Now 5 comes here but not in the other two numbers. 7 also is like that. See, not in the other two numbers, only here. So 3 is the highest common factor of these three numbers. Why we do not take 3 square and all here? See, 3 comes only once in all these numbers, no? That is why we take only 1 3. This is the second part of our third question. Here the same question but 3 different numbers, 17, 23 and 29. 17, 23 and 29. What is the peculiarity of these three numbers? All these three numbers are prime numbers. So what we can say? HCF. See, we cannot factorize 17. 17 can be written as 17 into 1. No other factors because it is a prime number. 23 is also like that. It is 23 into 1, and 29 can be written as 29 into 1. No other factors. See, which comes here as the common factor? 1. So HCF is equal to 1. Now what about the LCM? LCM means we have to consider all the factors with maximum power of each factor. Here all the factors comes only once, and factors are 17, 23 and 29, and 1 is also there. We no need to write it, right? Anyways, we have to do this multiplication. 17 into 23 into 29, we will get 11339 as the product. So this is the LCM. This is the third part of question. Find the LCM and HCF of 8, 9 and 25 using prime factorization method. Here I have factorized these three given numbers, 8, right, 9 and 25. So 8 can be written as 2 into 2 into 2. Okay, and 9 can be written as 3 into 3, and 25 can be written as 5 into 5. Okay, see, what will be the HCF, highest common factor? Any factor comes in common here? No. See, here it is only 2, here it is 3 and here it is 5. So there is no common factors, but we can consider this 1, right? So HCF is equal to 1. Now what is the LCM? LCM, we have to consider all the factors. See, 2 is a factor and 3 is a factor and 5 also comes as a factor, and we have to consider the maximum power of these factors. See, here 2 comes 3 times, so 2 cube. Next 3 comes here 2 times, so 3 square. 5 also comes 2 times. So this is actually 8 into 9 into 25. Okay, 8 into 25. See, 25 into 4, 25 into 4 is actually 100, right? So what is 25 into 8? See, 4 into 2 is 8. So it is 200. Okay, 25 into 8 is 200 into 9. So we will get 1800. This is the LCM of these three numbers. This is the fourth question of this exercise. See, given that HCF of 306 and 657 is equal to 9, find LCM of these two numbers. See, same numbers. Okay. See, in the important points we have learned that the product of two numbers is same as the LCM of those numbers multiplied by HCF of those two numbers. Okay, the product of LCM and HCF of two numbers is same as the product of the numbers. Let us apply here. See, here the given numbers are 306 and 657. This is same as LCM into HCF. Okay, actually LCM is not given in the question. We have to find it out. That is the question. And HCF is given as 9. Okay. So here we have this one. Now what is LCM? To get LCM, we have to take this multiplied by 9 to the next side of the equal to symbol. Multiplied by, when shifted to the next side, will become divided by. So 306 into 657 divided by 9. Okay. Here, to simplify the multiplication process, we can actually divide 657 by 9. Okay. Here 7 times, remainder 2, 27 3 times. So 306 into 73. Okay. We will get it as 2233 138. We have to do the multiplication and this will be the answer. This is the LCM of these two numbers. This is the fifth question of our exercise. Check whether 6 raised to n can end with the digit 0 for any natural number n. Okay? As it is the proof, we have to write the proof, right? So we will start the answer like this. Assume 6 raised to n can end with 0. We assume that 6 raised to n can end with 0. Any number which ends with 0, see 10, 20, 30, all these numbers are multiple of 5, right? In other words, we can say 5 is a factor of all those numbers which ends up with a 0, right? So we can say 5 is a factor of 6 raised to 1 according to 6 raised to n according to our assumption, okay? If we assume that 6 raised to n end with 0, then 5 is a factor of 6 raised to n. Okay, then actually what is 6 raised to n? 6 is 2 into 3, okay, raised to n. 6 can be written as 2 into 3, so 6 raised to n is 2 into 3 raised to n. This is same as 2 raised to n into 3 raised to n. Okay, is there any 5 coming here as a factor? See, we have factorized this number into prime factors, that is 2 and 3 are the only prime factors which will come in 6. So 5 is not coming here. So what we can say? Only 2 and 3 comes as the factors in the prime factorization of 6 raised to n, right? So our assumption is false. Our assumption was like 5 is a factor of 6 raised to n, which will not occur. So we can say 6 raised to n cannot end with 0. This is the sixth question of our exercise. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So first, we should know what is a composite number. Composite number can be expressed as product of primes. Okay, here the first number given is 7 into 11 into 13 plus 13. Okay, here this is a term and this is the next term. See, a plus symbol comes in between. Okay. What is common in these two terms? 13 is common. So I took 13 outside. See, 13 moved from this term means what is left here? 7 into 11. Plus 13 is moved from here. What is left here? Actually into 1 is there. So here 1 comes. See, 13 into something. 13 into some number is here. So 13 into, this is 77 plus 1, 78. Okay. See, this is the product of a prime number 13. This given number is a product of the prime number 13. So this is a composite number. Now let us take the next number given. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. See, a plus symbol comes here. So, 2 terms are there and 5 is common. So, I took 5 outside. Inside the bracket I will have 7 into 6 into 4 into 3 into 2 into 1. No need to write it, right? Here what is left? Yes, 5 into 1 is there. So, here comes 1. See, this is also a product of a prime number 5. The second number given in this question is a product of the prime number 5. That means these two numbers are composite numbers. This is the last question of our exercise. There is a circular path around a sports field. Okay, we have a circular path. Sonia takes 18 minutes to drive one round of the field. Sonia takes 18 minutes. Okay. Then to take one round. Then while Ravi takes 12 minutes. Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? At the starting point. Okay, suppose this is a starting point. Sonia can make a round in 18 minutes and Ravi can make it in 12 minutes. So who goes faster? See, less time is taken by Ravi. So Ravi goes faster. Okay, Ravi will go faster and Sonia will be behind. So when will they meet again? After they have started their journey. See, here the numbers are 12 and 18. Okay, going round means what is going on. See, 18 minutes for one lap. For the second lap, 18 into 2. For the third lap, 18 into 3, like that it goes. See, multiple of 18 comes here for Sonia. And for Ravi, it will be multiples of 12. The time taken to complete one lap will be 12 minutes. 2 laps 12 into 2. 3 laps 12 into 3, like that. So, when they meet again means we have to find the least common multiple. Why we are taking the multiple? See, 1 lap means 1 into 18. 2 lap means 2 into 18, like that. See, they are the multiples of these given numbers. So, when they will meet means we have to find the LCM, least common multiple of these two numbers. So, we will use prime factorization. 9, 3, 3. Here it is 6 and 2, 3. Okay. So 12 is equal to 2 into 2 into 3 and 18 is equal to 2 into 3 into 3. So what is the LCM? LCM means we have to consider all the factors. 2 is there and 3 is there and we have to take the maximum power of each factor. See, 2 comes here 2 times. That is the maximum. Here it is only for 1 time. 3 here only 1 time, but here it is 2 times. So it is 2 square is 4 and 3 square is 9. So this is 36 minutes. Okay, at 36th minute they will meet each other. Thus we have completed all the questions in this video. Hope all of you could understand. Thank you.